Yo, thank you for coming today. So today I will talk about real-time security on Kubernetes. But just before we start, let me introduce myself. So my name is Mohamed. I am a cloud platform engineer at Cloud Pilot. We are actually a consulting company. So we help one of our expertise, we help other countries migrate to the cloud. So by the way, we are hiring a cloud engineer, cloud architects. If you need, you can talk to me or visit our website later. So small disclaimer, I am not a cybersecurity expert, but this is part of my master thesis, and I did a lot of search and background. So today, actually, we are trying to answer the question, what are the main challenges in implementing a highly autonomous AI agent for real-time threat remediation? But we will go through a real use case, then we will define what autonomy is, what real-time is, and then we will answer the question. So let's go. We are going back to February 2018 in Silicon Valley in a company called Redlock. This is, by the way, one of the biggest cybersecurity company in the world, later acquired by Palo Alto. We have our cloud engineer or security engineer. Let's call him Jack. Jack was scanning the public internet for malicious or unsecured cloud server or misconfigured cloud servers. He spots something that should never happen. So an open server with no password. He clicks in, and then he finds out that this is actually running a Kubernetes cluster. And this Kubernetes cluster is actually doing a crypto mining. Then after further investigation, he found out that this belonged to one of the biggest US car companies manufacturer, I think you guessed it, the company Tesla. What's actually happened is that the attackers went through this open door, they grabbed the keys, and they started in the background a cluster, a Kubernetes cluster who is running crypto mining. So that means Tesla is paying AWS for the cloud infrastructure, and the attackers are using this infrastructure for crypto mining. So that means Tesla is paying actually the attackers. So you can imagine how much it costed, and for fun, maybe also how when Elon Musk see the bill, so what was his reaction? So how many times he says, you are fired? But yeah, this is not our topic. Let's go back to our topic. Actually, what happened is that Redlock reported the issue, and Tesla handled it or fixed it within 24 hours, and they said the user data were not touched, and so on, but who believe it? The question is how long it takes, or how long went the attackers were undiscovered, and how long it takes to, or how much it costs, the loss can cost. So some experts report millions of dollars lost, but the real amount or the real value were never revealed. So the question is, or the takeaway from this short story is, each second of a delayed response can cost company a lot of money. Now imagine you have an AI agent in your Slack. He can read millions of logs at once. He can rotate the keys. And then before you type a key in your keyboard, he can immediately isolate the service and rotate the keys and redeploy a new version or a new signed version of your system. So you can have your summary or the summary of the logs with coffee in the hand. That would be awesome, isn't it? I think it helps a lot the cybersecurity people. Yeah, let's go to the next one. Okay, let's tackle the core problem. The core problem is that the attackers' runtimes went in seconds, a human don't. We usually need to read logs, to align on Slack, and to ask for approval. And in meanwhile, while we are doing that, the blast radius grows and the client bills climbs. Because in Kubernetes, minutes are a luxury. If we fail in fast containment, we will pay. We will pay in downtime, in money, or in both. So the real question isn't if we can detect it, because we usually can, but the real problem is, or the right question is, can we act in time? So before we dive in, as promised, let's first define what autonomy is. When I talk about autonomy, I don't mean science fiction. What's really mean is bounded helper who can cut network paths, rotate keys, isolate servers, and kick off a clean redeploy of my system without waiting for me. So the agent has a clear scope, managed Kubernetes, and runtime threads. Not everywhere, not everything. So here how we can have like, it's fast, it's reversible, and it is auditable. Okay, yeah, now that we defined what autonomy is, let's go for real time. For real time, what does it mean real time? And we have actually two scopes, containment and remediation. For containment, when it's handle the critical issues, we need to move from 1 to 5 seconds, when non-critical issues from 10 to 30 seconds. For remediation, we need to have a clean rollout, so clean rollout in 2 to 5 minutes, plus a rollback or automatic rollback ready before the 10 minutes Kubernetes deadline. If we hit these targets, the users don't notice and the finance doesn't care. To beat this challenge or to hit these targets, we need to use, or it's better to use a Kubernetes native first approach. Because speed lives inside the cluster. Tightening a network policy or evicting a pod can propagate in seconds. But on the other hand, in the cloud, changing a firewall rule, or VPC firewall rule or security group, that can take a dozen of seconds. And here we are losing a lot of money and a lot of valuable time when dealing with the cloud API. So the good thing, the good trick is to use a two-steps strategy. So the first steps we contain inside the cluster, and then for the second step, we go slowly with the cloud hardening after the fires goes out. So yeah, let's now go to the one of the biggest challenge actually, which is safety, because safe is useful only when it is fast, or fast is useful only when it is safe. For that, we need to wrap up our agent inside seatbelt. And the first seatbelt is policy as a code. So the agent has clear rules, what to touch, where to touch, and what to touch. The second seatbelt is blast radius limit. So the agent has also a clear scope. It will scope only labels and namespace, not the whole cluster. Then we can also use a progressive delivery. That means we can fix a small traffic, or we can fix a small slice of the traffic, and then look for health check. If it drops, we can immediately use our auto rollback. If not, we can continue our progressive delivery. Then it's also very useful, kill switch and rate limits. So we give the people the possibility to pause at each time or to slow down the process. If you can imagine things get very noisy and people need something like that, they have the possibility to immediately stop. One of the important things is also immutable logs. So every step is logged, or every step is logged and recorded. So the security and compliance people, they have their receipt at the end. So here how we can get speed and trust together. Okay, here's how it plays out. The first phase is the detection phase. We have an agent, he can correlate or he can spot patterns. Let's take, for example, we have an egress traffic with a risky behavior that will lead to a confidence spike in the agent. That means the agent will have more confidence that it's really a threat. So he can tackle the next phase, which is the quarantine phase. I define it T plus 3 seconds, where the traffic or the agent will fence off, so will contain the risk, will cut the network, no in, no out, and the blast radius will stop immediately. And then he can go to the canary phase, which is T plus 45. What does it mean? He will start rolling out the silent version of our systems, but in a small traffic or small slice of the traffic. Then we go to the last one, which is the decision one, the T plus 5 minutes, where the agent will check the health checks. If it's green, he continue the process, so he go back to the step, the canary step. He can continue rolling out to another small traffic of the system, and then if not, he can immediately trigger an auto rollback of the system. So in this case, you have users that continue buying, so you generate revenue. You have finance that see a flat bill or a flat bill, the cloud bill will be flat, so you save money. And you have your audit log saved, so you have an audit or trail later, not a 3 a.m. incident. Okay, I prepared a small adoption checklist that you know if you are ready or not for that. And the first one is you need to check if your CNI can enforce network policy. And the most important thing that you need also to measure how long it takes. The next, you need to check your policy as a code. You need to have a policy as a code with clearer ownership. Then you need to check, or you need to have a pipeline that can do canary and auto rollback without drama. Then each logs and tickets, as we say, or each auto action must trigger or must create logs and tickets. And then also the important thing, kill switches and rate limits, you must have that to give the people the possibility to stop at each time, to slow down the process. And yeah, that's also very important. So if you can tick these boxes, start with containment only first, build your trust, and then you can go for remediation later. Now let's see when you need to hit pause, when not to automate. Because I think that autonomy is not a switch that you flip everywhere. If you have noisy alerts and weak observability, actually you are only automating confusion. That you don't want that. Then if you don't have a fast rollback, any bad fixes can generate a big incident. So it's not for you. The next thing, ownership. If you have a fuzzy ownership, or your ownership is fuzzy, and you don't have audit trail, governance will immediately stop you. And this is rightly so. Then if you are highly regulated and you don't have pre-approval guardrails, just stop. First, fix these things. Then think about automation, or you can start actually trying automation. I have some quick wins that you can start immediately next week. And first, so the principle, start small, prove value, and then scale fast. But the first thing that you need to check, or you can try, is to auto-apply a quarantine network policy, but in the highest, only take the highest confidence alerts. It's about containment only. Then you can add a preview mode comment to your tickets, so the agent know exactly what to do or which process he is. It's about isolation or something else. Then it's also very important, you need to measure your P95 containment time end-to-end, but only in staging mode. So you know exactly your real second, and it's not about guesses. So you know exactly your real seconds. Okay, now that I come to the last slide, autonomy, again, here isn't science fiction. It's fast, bounded, reversible. You can first start with containment only, build the trust slowly, and then go for the remediation. So thank you again for listening, and I will be happy to tackle your question.